Hi, you just acquired your BS degree in biomedical sciences and you're applying for laboratories in the area. You did get a call back from one laboratory and they have looked at 10 possible candidates and are asking for a second round of interviews. This time, they're checking for your applied science skills by the use of the micropipette. So let's say a company gives you a green dye solution and they also give you a tube of water. And they want you to make solutions that are at 100% green dye all the way to 0% green dye in increments of 20%. We can do that very simply using the C1V1 equals C2V2 equation, and then we can figure out how much green dye we need to add to each of our microcentrifuge tubes, and then we can also figure out how much remaining difference we have if we subtract the amount of green dye for each of those concentrations and then add the water in there. One thing a company looks for is trying to save as much material as they can without expending too much. So it's always wise to go with at least one solution first and then change your tip and then add the next. So my first solution is going to have just water anyway, but the one thing I want to make sure is I have a nice tight seal of my tip onto my micropipetter and that I have my range setting correctly, so at 400 microliters. Notice I don't want to go over or above the range, and I want to go ahead and take my tip and place it just below the water so that way I do not extract any air. Secondly, I want to make sure that my plunger is pushed down to the first stop. That is for your actual measurement. Place your tip into the water just below the surface and slowly draw up. Remember, if it's a thicker solution, it's going to take a little bit longer for that higher viscosity to make its way up the tip. Now that I've added water to all of my tubes, I can now add my volume of green dye in the remaining microliters that were subtracted from the 400 microliters total volume. Let's go ahead and do that now. Remember, you always want to mix your solutions, so either go ahead and pipette up and down from lowest to highest concentration, or you may want to go and vortex this materials to make sure that your solution is homogeneous. Now you're ready to aliquot your samples into a 96 well plate so that it can be read by a spectrophotometer. It's always best to apply your samples in triplicates so you can get an average score of your absorbances. Now that you've completed your samples in triplicate, we need to take your plate of your different dilutions to the plate reader or the spectrophotometer. So let's do that. As the plate reader or spectrophotometer is analyzing your samples, don't forget Beer-Lambert's law is taking place, in which the absorbance of a solution is directly proportional to the concentration of the analyte within each solution. So remember, how effective your pipetting is translates to the amount or volume that you have in each well. Consistent pipetting leads to consistent results, and therefore the absorbances should be very similar with little variation. The spectrophotometer is a machine that passes light through a sample. If the sample has a higher concentration, then light will be absorbed more readily. Let's go ahead and put our 96 well plate onto the spectrophotometer carriage. You want to make sure that your plate is lined up with the carriage as well. A1 goes to A1. And again, we have samples that are 0 concentration to highest concentration in row F. Remember, we made up our own 35% concentration in row G, and we would expect that absorbance to fall between our 0 and our 100% green concentration. It's all going to be in the details of what our spec reads are. The moment awaits, and the spectrophotometer has spit out raw data reads that you can blank correct, average, and then plot into a standard curve. You can check your R-squared value, and if it is close to 1, your pipetting is pretty accurate. Remember we made a green solution between 0 to 100%? If you made a different solution at a different concentration, say 35%, you can use your linear equation to determine that value of that concentration. And if it's close to that 35% with a relative percent difference of less than 5%, then you are excellent at pipetting.